Good morning, students. So today we have lecture number 9 and we are solving the numericals. We are solving the numericals. Write down the next numerical. Next numerical. Two charges minus three charges minus Q plus capital Q and minus Q plus capital Q and minus Q are placed at equal distances. Three charges minus Q plus capital Q and minus Q are placed at equal distances on a straight line. Three charges minus Q plus capital Q and minus Q are placed at equal distances on a straight line. You please stop. If the potential energy of the system of three charges is 0, if the potential energy of the system of three charges is 0, if the potential energy of the system of three charges is 0, if the potential energy of the system of three charges is 0, find the ratio capital Q divided by small q. Find the ratio capital Q divided by small q. Find the ratio capital Q divided by small q. Okay. So first understand the question, then try to solve. So what they have given? Three charges minus Q plus Q and minus Q are placed at equal distances on a straight line. So let us consider minus Q plus Q and minus Q are placed at points A, B and C. Let us consider that minus Q plus Q and minus Q are placed at points A, B and C such that this AB is equal to BC and that is equal to, take some value you take it as R. I'll just take it as R. So they are given equal distance. Okay. Three charges minus Q plus Q and minus Q are placed at equal distances on a straight line, right? If the potential energy of system of three charges is 0, find the ratio. It is, so now the potential energy of the system of three charges, the potential energy of system of three charges, that is given by U is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 Q2 Q3 divided by R23. This is formula. Potential energy of system of three charges. U is equal to 1 by 4 pi epsilon Q1 Q2 divided by R12. R12 is the distance between Q1 and Q2. R13 is the distance between Q1 and Q3. R23 is the distance between Q2 and Q3, and according to the given question, and it is equal to 0. According to the given question, they have given that potential energy of system of three charges is 0. Let us take this as Q1, this as Q2 and this as Q3. This is Q1, this is Q2 and this is Q3. Okay. So now substitute the values. So U is equal to 1 by 4 pi epsilon naught Q1 Q2, Q1 minus Q, Q2 means plus Q. So it is minus Q into plus capital Q divided by R12. Distance between minus Q and plus Q is R. So R plus this plus Q1 Q3, Q1 Q3, Q1 Q3. So it is minus Q into minus Q, and distance between minus Q and minus Q, that is this one, that is will becomes 2R. From here to here distance is 2R. So therefore it is 2R plus Q2 Q3, Q2 Q3, that is plus Q into minus Q. plus capital Q into minus Q, and distance between them is R, and that is equal to 0. That is equal to 0 because they are given. So therefore, now take the common Q by R. Q by R is taken common. So that is Q divided by 4 pi epsilon naught R is taken common. So here it is only minus Q, plus into minus, minus Q, minus into minus plus, so plus only. So 1 Q is taken common, so Q divided by 2, and there Q plus into minus capital Q is equal to 0, right? So now take this entire thing that side. So therefore you will get minus Q plus Q by 2 minus Q is equal to 0, right? And minus 2Q, minus 2Q send that side, it will become plus 2Q. So Q by 2 is equal to 2Q, and what they want? They want is Q by Q, it is capital Q divided by small q. So take this small q that side to this side, you will get 1 by 4. So capital Q divided by small q is 1 by 4. So 1 by 4 is the answer. Capital Q divided by small q is 1 by 4. 1 by 4 is the answer. Understood? Okay. So now next problem. Understood? Simple. Huh? Okay. Next problem. Write down the next problem. Write down the next problem. Two positive point charges of 0.2 microcoulomb, 2 positive point charges of 0.2 microcoulomb and 0.01 microcoulomb, 2 positive point charges of 0.2 microcoulomb and 0.01 microcoulomb, 2 positive point charges of 0.2 microcoulomb and 0.01 microcoulomb are placed 10 centimeter apart, apart. 2 positive point charges of 0.2 microcoulomb and 0.01 microcoulomb are placed 10 centimeter apart. Give please stop. Calculate the work done. In reducing the distance. Calculate the work done in reducing the distance to 5 centimeter. Calculate the work done in reducing the distance to 5 centimeter. Calculate the work done in reducing the distance to 5 centimeter. Calculate the work done in reducing the distance to 5 centimeter. Okay. First understand the problem. So two charges are there. It is, I will say this as Q1 and I will say this as Q2. Q1 is equal to 0.2 microcoulomb, Q2 is equal to 0.01 microcoulomb are placed 10 centimeter apart. This is initial separation. This is RI, I will say initial separation. Okay, initially they are 10 centimeter apart. It is 0.1 meter. And calculate the work done in reducing the distance to 5 centimeter. So that is final separation. Calculate the work done in reducing the distance to 5 centimeter. So final separation, it is RF is equal to 5 centimeter. That can be done as 0.05 meter. And calculate the work done. W is equal to question mark. Here, understand the question. Initially, Q1 and Q2 are at a distance of 10 centimeter. Okay, 10 centimeter. Both are positive charges. Repel each other. Okay, so they have to brought to a distance of 5 centimeter. They cannot come on their own to a distance of 5 centimeter because both of them will positive and they will repel each other. Hence, an external work has to be done. that external work has to be done, and that external work done we have to calculate. That is work done to bring them to a distance of 5 centimeter. To bring them to a distance of 5 centimeter. I will call this as initial position, this as final position. This is final position, this is initial position. So initial separation is 10 centimeter, so final separation is 5 centimeter. So now we want work done, simple. So we know that work done is equal to the change in potential energy. We already know this one. Work done is equal to change in potential energy. So that is W is equal to delta U. W is equal to delta U, and delta U is nothing but change in potential energy. That is final potential energy minus initial potential energy. UF minus UI. UF is final potential energy, UI is initial potential energy. So now write the formula. So therefore W is equal to UF. It is final potential energy. Potential energy of system of two charges. Potential energy of system of two charges in the final position. This is final position, this was initial position. So that is final position 1 by 4 pi epsilon naught Q1 Q2 divided by RF, because distance is final distance is 5 centimeter, right? Minus potential energy of system of two charges in initial position 1 by 4 pi epsilon naught Q1 Q2 divided by initial distance, that is Ri. Got the idea? So now taken common, so it is Q1 Q2 divided by 4 pi epsilon naught is taken common. So you will get 1 by RF minus 1 by Ri, right? So now substitute the values. So W is equal to Q1 is 0.2 into 10 to the power minus 6. 0.2 microcoulomb, that means micro means 10 to the power minus 6. Q2 0.01 10 to the power minus 6. 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9. 1 by RF is 0.05 minus 1 divided by Ri is 0.1 meter, right? Now do the simplification, you will get the answer. Do the calculation on your own, I will not do the calculation. So the answer I will tell, the final answer will come out to be 1.8 into 10 to the power minus 4 joule. 1.8 into 10 to the power minus 4 joule. After doing the calculation, you will get 1.8 into 10 to the power minus 4 joule. So check out the calculation, I checked it, just cross verify. 1.8 into 10 to the power minus 4 joule. Understand? The question is, initially the charges are at a separation of 10 centimeter. Later on they have to brought it to a separation of 5 centimeter by doing an external work. And that external work we have to find, and that we know that work done is equal to change in potential energy. Work done is equal to change in potential energy. So W is equal to delta U, and delta U is UF minus UI, and substitute the values and simplification, you will get the answer. Understood? Okay. So now next question, write down the next question. These are our questions you have to solve. So you will get more and more ideas, different type of ideas. Okay. Next question. Two electrons, write down, two electrons each moving with a velocity of 10 to the power 6 meter per second. Two electrons each moving with a velocity of 10 to the power 6 meter per second. Two electrons each moving with a velocity of 10 to the power 6 meter per second. Two electrons each moving with a velocity of 10 to the power 6 meter per second, are released towards each other. Two electrons each moving with a velocity of 10 to the power 6 meter per second, are released towards each other. You please stop. Are released towards each other You please stop. What will be the closest distance of approach between them? What will be the closest distance of approach between them? What will be the closest distance of approach between them? What will be the closest distance of approach between them? Question mark. What will be the closest distance of approach between them? Okay. Understand the question properly. Two electrons initially they are moving with a velocity of 10 to the power 6 meter per second. Each electron is moving with a velocity of 10 to the power 6 meter per second, and they are coming towards each other. They are moving towards each other. And what will be the closest distance of approach between them? Okay. So here two electrons. First understand. I am explaining. Two electrons. So electrons, we know that electrons are negatively charged. So they are not at rest. Initially they are not at rest. Initially they are moving with a velocity of 10 to the power 6 meter per second. This is also, and this also moving with a velocity of 10 to the power 6 meter per second towards this one and towards this one. They are coming to close to each other. Okay. See the situation. Both have the initial kinetic energy. And they are moving towards each other. Both are negatively charged. And they will repel each other. So hence, as they move closer to each other, they will lose the kinetic energy. And they will gain the potential energy. That is, the kinetic energy of the electrons is converted into potential energy as they move closer and closer to each other. Understood my point? Initially they are in the motion. From the beginning only they are in the motion with a velocity of 10 to the power 6 meter per second. As they come closer and closer, they will start to lose the kinetic energy and they will gain the potential energy. And to what minimum distance they will approach. That is, we have to find the distance of closest approach. What will be the distance between the two electrons? That is the minimum distance between the two electrons before they stop. See here, as they lose the kinetic energy, finally kinetic energy becomes 0. At a certain distance, the kinetic energy becomes 0, and that entire kinetic energy is converted into potential energy. Understood the point? As they come closer and closer, the kinetic energy goes on decreases. At a certain distance, the entire kinetic energy is converted into potential energy. When the kinetic energy becomes 0, then they will come to rest. And that will be the distance of closest approach. Understood? Got the idea? At a particular distance between them, the entire kinetic energy is converted into potential energy. So the point or the situation where entire kinetic energy is converted into potential energy, at that situation, that will be the minimum separation between the two charges. Understood? So let R0 be the distance of closest approach. Between two electrons. Okay. At this distance of closest approach, at this distance, the entire kinetic energy is converted into potential energy. At this distance, the initial kinetic energy, that is our total kinetic energy, is converted into potential energy at distance R0. Potential energy at distance R0. What the idea? It is the initial kinetic energy, whatever the initial kinetic energy both had, as they come closer and closer, the kinetic energy decreases and the potential energy goes on increases. At a particular separation, the entire kinetic energy is converted into potential energy. Potential energy at the distance R naught. Understood? So initial kinetic energy is equal to potential energy at distance R naught, and initial kinetic energy of one electron 1 by 2 mv square plus initial kinetic energy of another electron 1 by 2 mv square, and potential energy of system of two charges 1 by 4 pi epsilon naught q1 q2. Shall I write? Okay, I will write here q1 q2 divided by distance between them. We have taken it as r naught, because at the distance of r naught only the entire kinetic energy is converted into potential energy. So now q1 and q2 is nothing but charge of the electron. So that is 1 by 2 mv square plus 1 by 2 mv square can be written as mv square is equal to 1 by 4 pi epsilon naught, and q1 into q2, that is E into E divided by r naught. So therefore distance of closest approach, that is r naught, is equal to distance of closest approach. We want distance of closest approach. So r naught is equal to 1 by 4 pi epsilon naught E square divided by mv square. What is E? E is the charge of an electron, and m is the mass of an electron, and v is the velocity of an electron. Understood? E is the charge of an electron, m is the mass of electron, and v is the velocity of the electron. And r naught is equal to 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Charge of an electron, that is 1.6 into 10 to the power minus 19 whole square divided by m, mass of the electron. M is 9.1 into 10 to the power minus 31 kg. Mass of the electron, you must know all these constant values. 9.1 into 10 to the power minus 31 kg, mass of the electron, and velocity they have given 10 to the power 6, 10 to the power 6 whole square. This mass of the electron, charge of the electron, all these things you must know, all these constant values. So now do the simplification, you will get the answer. Do the simplification, I will just directly tell the answer. R naught is equal to, you will get R naught as, you will get 2.53 into 10 to the power minus 10 meter. 2.53 into 10 to the power minus 10 meter. Do the calculation and you will get the answer as 2.53 into 10 to the power minus 10 meter. This is the distance of closest approach between the two electrons. See, one more point. This concept, it is concept of distance of closest approach. We will study in detail. We will study in detail in the modern physics. That is in the second part of the physics. That is in atomic physics. It will come, and here we are solving. We are finding the distance of closest approach by using the potential energy of system of two charges. It is potential energy of system of two charges can be used to determine the distance of closest approach between the two charged particles. The distance of closest approach between the two charged particles can be determined by using the potential energy of system of two charges. Understood? This is application, and how to do it I shown. You must try to do some other similar type of problems. Okay. Next problem. Next problem, write down the next problem. Okay. Next problem. Two particles have equal masses of 5.0 gram. Two particles have equal masses of 5.0 gram. Two particles have equal masses of 5.0 gram each, and opposite charges of plus 4 into 10 to the power minus 5 coulomb and minus 4 into 10 to the power minus 5 coulomb. Two particles have equal masses of 5.0 gram each and opposite charges of plus 4 into 10 to the power minus 5 coulomb. Plus 4 into 10 to the power minus 5 coulomb and minus 4 into 10 to the power minus 5 coulomb. Give list of They are released from rest. They are released from rest. They are released from rest. That means initially they are at rest. They are released from rest. With a separation of, they are released from rest with a separation of 1.0 meter. They are released from rest with a separation of 1.0 meter. They are released from rest with a separation of 1.0 meter between them. They are released from rest with a separation of 1.0 meter between them. You please stop. You please stop. Find the speeds of the particles. Find the speeds. S-P-E-E-D-S. Find the speeds of the particles when the separation is reduced to 50 centimeter. Find the speeds of the particles when the separation is reduced to 50 centimeter. When the separation is reduced to 50 centimeter. Find the speeds of the particles when the separation is reduced to 50 centimeter. Okay. So, understand the question, what they are given. Two particles have equal masses of 5.0 gram each. That is mass of the particles. Two particles is 5.0 gram. So, write it in kg. It is 5 into 10 to the power minus 3 kg. Right? So, two particles have equal masses. So, both have same masses and opposite charges. That is Q1. Q1 is plus 4 into 10 to the power minus 5 coulomb and Q2 is minus 4 into 10 to the power minus 5 coulomb. That is means one is positive charge, another one is negative charge. They are released from rest with a separation of 1.0 meter between them. This is the initial separation. This is the initial separation. Initial separation. Right. Find the speeds of the particles when the separation is reduced. So, final separation. Final separation. It is R2 is equal to 50 centimeter. And this 50 centimeter can be written as 0.5 meter. And find the speeds of the particles. Speeds. That is velocity we have to find. See here, in the previous question, just now we have solved another numerical, that is distance of closest approach. In that question, both the electrons were initially in motion. Initially they had the velocity, and when they reach a particular distance of closest approach, that particular distance of closest approach we have to find. Okay. So now in this question, initially they are at rest. See here, initially they are at rest. They are released from rest. Initially they are at rest, and the initial separation between them is 1.0 meter. Okay. So one is positive charge, another one is negative charge. So one is positive charge, another is negative charge. They will attract each other. One is positive, another one is negative. So they will attract. Initially they were at rest. They were at rest means initial kinetic energy is 0. Initially they had only potential energy. And when they are released, they will attract each other and they will move towards each other. And when they move a distance of 50 centimeter, when the separation between them is 50 centimeter, what is the speeds of each particle? Understood the question? Did you understood the question? So it is, so if you take initially Q1, Q2, this one is positive charge, another one is negative charge, and initial distance between them is 1.0 meter. Okay. They are released from rest. Initially they are at rest, so they are released. Released means they will start to move. That is, some negative charge will start to move towards positive charge, and positive charge will move towards negative charge. And when the separation between them is 50 centimeter, when the separation between them is 50 centimeter, at that situation, what is the velocity of each particle? What is the velocity of each particle? Understood the question? Okay. So how to solve it? So this can be solved by using the law of conservation of energy. That is, total energy is conserved. So it is, total energy is conserved. That is, total initial energy. That is, total energy at the initial position. I will say this as the initial position. That is when the distance between them is 1.0 meter, that is the initial position. When the distance between them is 50 centimeter, that is the final position, I will say. Okay. So total initial energy is equal to total final energy by using a law of conservation of energy. Conservation of energy. We can write so total energy at initial position is equal to total energy at final position. Total energy at initial position will be equal to total energy at final position. Total energy at initial position, initially they were at rest, so kinetic energy is 0. So initially they had only potential energy. So total energy at initial position will become completely potential. That is potential energy 1 by 4 pi epsilon naught Q1 Q2 divided by initial distance R1. Initial distance R1 R1. And total energy at final position. At this position, when the distance between them is 50 centimeter, they will have kinetic energy as well as potential energy. When the distance between them is 50 centimeter, they will have kinetic energy as well as potential energy. Remember that at the distance between 50 centimeter, they are not at all stop. They did not stop. At this position, what is the speed they are asking? Understood? Hence, they will have both kinetic energy and potential energy. That is, kinetic energy at distance of 50 centimeter plus potential energy at distance of 50 centimeter. Kinetic energy at distance of 50 centimeter plus potential energy at distance of 50 centimeter, that will become total energy at final position. So therefore, you can write 1 by 4 pi epsilon naught Q1 Q2 divided by R1. And kinetic energy, that is, we will say it as 1 by 2 mv square kinetic energy of one particle and kinetic energy of another particle 1 by 2 mv square plus potential energy at distance of 50 centimeter, that is potential energy 1 by 4 pi epsilon naught Q1 Q2 final position, that is 50 centimeter position, that is R2. So now simplify this one. We want velocity. Add these two. Q1 Q2 divided by 4 pi epsilon naught. I will take it as common. Okay. Directly I am writing. These two are added. mv square. Q1 Q2 divided by 4 pi epsilon naught. Q1 Q2 divided by 4 pi epsilon naught I am taking common. So here you will get 1 by R1 minus that term is taken to this side. So it will become minus 1 by R2. Okay. So now substitute the values and get the answer. So that is we want values now. Okay. So mv square, that is v square is equal to Q1 Q2 divided by 4 pi epsilon naught into m, that is mass taken that side. So into 1 by R1 minus 1 by R2, that is R2 minus R1 divided by R1 into R2. You can write like this. So now substitute the values and you will get the answer. So v square is equal to Q1, that is plus 4 into 10 to the power minus pi coulomb. Q2 minus 4 into 10 to the power minus pi coulomb. And mass is how much they are given? 5.0 gram, that is 5 into 10 to the power minus 3 kg. And 1 by 4 pi epsilon naught becomes 9 into 10 to the power 9. And R2 value, R2 is final position means 50 centimeter. 50 centimeter means 0.5 meter minus R1 initial position, that is 1.0 meter divided by 1 into 0.5. So now simplify this one. You will get the answer. I will write directly answer. You do the calculation on your own. The answer will come out to be 2880. That is v square is equal to 2880. And now v is equal to, now we want velocity. So v is equal to we will get 53.67 meter per second. 53.67 meter per second. So this is the velocity of each particle at the distance of 50 centimeter. At a distance of 50 centimeter, velocity of each particle, both the particles have the same velocity, 1 by 2 m square, 1 by 2 m square. So v is equal to 53.67 meter per second. Got the idea? So this is how you can get the velocity if initially the charges are at rest, and in the previous question we have got the final position if initially they had the velocity. So by using the potential energy. Okay. So next to homework, write on these two homework, write on the homework. So same type of questions, so just to write the homework, write on 2 point charges, 2 point charges plus 10 microcoulomb and minus 10 microcoulomb. 2 point charges plus 10 microcoulomb and minus 10 microcoulomb are separated by a distance of 2.0 centimeter in air. 2 point charges plus 10 microcoulomb and minus 10 microcoulomb are separated by a distance of 2.0 centimeter in air. Give a list of first one. Write down first one, in that only first one. Calculate the potential energy of the system. Calculate the potential energy of the system, comma, calculate the potential energy of the system, comma. Assuming the zero of the potential energy to be at infinity. Assuming the zero of the potential energy to be at infinity. Assuming the zero of the potential energy to be at infinity. In that only second one. In that only second one. Draw an equipotential surface of the system. Draw an equipotential surface of the system. This is homework. Draw an equipotential surface of the system. I will give the answer. The answer for first one, that is calculate the potential energy of the system, that is equal to minus 45 joule. We will get minus 45 joule, and the diagram, that is 2 charges plus 10 microcoulomb minus 10 microcoulomb. This I have told you already in the lecture number 5 or 6. So in that equipotential surfaces, while explaining all that things, I have drawn the diagram. You refer to that video, you will get the answer. That is you have to draw the diagram for plus 10 microcoulomb and minus 10 microcoulomb equipotential surfaces. Okay, next homework, last one, write on another homework. 2 point charges, 2 point charges A and B. 2 point charges A and B. 2 point charges A and B of values for plus 15 microcoulomb. 2 point charges A and B of values plus 15 microcoulomb and plus 9 microcoulomb. 2 point charges A and B, capital A and capital B, of values plus 15 microcoulomb and plus 9 microcoulomb are kept 18 centimeter apart in air. 2 point charges capital A and capital B of values plus 15 microcoulomb and plus 9 microcoulomb are kept 18 centimeter apart in air. You list off. Calculate the work done. Calculate the work done when a charge B is moved. Calculate the work done when a charge B, capital B. Calculate the work done when a charge capital B is moved by 3 centimeter. Calculate the work done when a charge capital B is moved by 3 centimeter towards A. Calculate the work done when a charge capital B is moved by 3 centimeter towards capital A. Okay. Solve this one on your own, and the answer for this one is 1.35 joule. Answer for this one is 1.35 joule. So solve these questions, these two questions. Hope you are solving all the homework questions, and I will solve some more numericals in the next class.